Okay, I hope you were able to see the previous video for this lab number 3. I'm gonna go ahead and check each of the switches and each of the routers and server configurations just to make sure everything is working properly. And so the module 3 is about building a layer 2 layer 3 fabric with VLT, just like in the previous videos. The only difference is that this time I I am configuring the OSPF routing protocol for the northbound. In this case, let's call this router 3 and router 4, just to keep it within this scenario. Okay, so let's go ahead and read a little bit here. This module demonstrates the use of VLT, virtual link trunking, in Dell EMC Smart Fabric OS 10.5.1. This is the version for this GNS3 Lab. So the VLT is a layer 2 multi-pathing technology. So we have a device here, it can be a server, it can be storage, and it has actually dual path provided by these two switches in VLT mode, joined by a couple of VLTI, which is a couple links to that will help the VLT process to synchronize ARP information, MAC address, MAC table information from one peer to the other, IPv6 neighbors, because that's what is used for this VLT domain to exchange information. And also, if you have orphan ports that are not part of a VLT port channel, then there is that traffic that is going to be going across these two switches, but the user data traffic is not going to go through those links unless there is a failure somewhere in the topology. So having said that, let's go ahead and check. Let's go ahead and check switch 1 and switch 2. Those are the VLT peers. So I have switch 1 and then switch 2 side by side. So let's make this. Let me see if I can make this bigger. Let's go ahead and try that. There you go. Okay, so let me go to switch number 1 and let's do Control C to get back to the command prompt. Let's do the same. Well, on the second switch I need to actually log in. Admin, and I'm gonna wait. Okay, now I am in exec mode. So what I'm gonna do here, I'm gonna go into the config terminal. In this case, what I'm gonna do, I'm gonna go ahead no exec timeout, so that way it stays longer here without kicking me out. So let's go here and do the same config, and then let's go ahead and do no exec timeout, and then let's do exit. Okay, now let's go ahead and do the show run just to see the configuration. Okay, so that's switch 1 on the left. Let's do the show run on the right. Show run, and let's go ahead and see if I can do show run, but I'm gonna go back to exec mode and let's do show running configuration. Let's have them side by side to point out a few things. Okay, on this particular switch, this switch, the virtual version of OS 10 is based on a virtual S5248 switch, which is a 25 gigabit capable switch with 48 ports, and it has a couple of dual 2x100 interfaces and 4x100 ports that can be used for uplinking or in breakout mode. Okay, having said that, so if we take a look over here, the host name is switch 1, that's fine. Over here the host name is switch 2, which is fine as well. Let's go ahead and see the password is encrypted, so that's good. And one thing to mention here is that these switches are capable of doing the virtual routing and forwarding that will allow you to partition a single switch into multiple switches, each partition with its own routing table and all that control and data plane information isolated. And you can call them not just numbers, but you can also name them. For example, there is a VRF default that is the one that ships with the installation of OS 10. But you can add a VRF management, for example, so that way you can place your management interfaces into that VRF isolated from the default VRF. You can also create additional partitions, right? Each one with its own routing table. And those additional partitions, you can call them, for example, VRF red, VRF blue, VRF green. You can name those virtual routers, those virtual switches, for example, and that way you can have some type of multi-tenancy. But in this case, we just have the default. Let's see what else is okay. So another thing is that on the previous videos, we have port groups in the 5248. Every 4 ports you have a port group. So I'm just gonna mention it real fast, even though I talk about it in the previous lab 2 video. So port group 111 is gonna how to say this, is gonna have 4 physical ports in this port group. Is gonna be port 1, port 2, port 3, and port 4. And in port group 112, you're gonna have the other 4 ports, which is gonna be 5, 6, 7, and 8. And then and so on and so forth, all the way till you get to port group 12, which is gonna be the last 4 ports of those 48 ports of 25 gig. If you go to port group 113, this one is the dual 100 port I was telling you about, that you can use it in breakout mode. But normally what I like to do is to use port 13 and 14 for the VLT. So basically you use a 2x100 dual density cable to do the VLTI link. Let's see, let's go and see what else we have. So for port 16, port group 15, port group 16, port group 17, and port group 18, those are going to be the last 100 gigabit ports on that S5248 that are all the way to the right of the switch. The configuration that I loaded into the running config by doing the copy command, basically configure the switch for this lab. Interface VLAN not shutdown, interface VLAN 200 with the IP address of 10.1.1.252/24. And on the second switch, like I mentioned on the previous video, but it's worth, whenever you hear a good song, it's always good to hear it a few times, especially if you're going to be working with these switches. The more that you hear things over and over, the more that you're going to be internalizing stuff. So on switch 2, instead of having the 252, we're going to have for VLAN 200 253, and there's going to be a virtual IP address for the VRRP group, the virtual redundancy routing protocol, and the virtual IP address that need to be set in both switches is going to be 10.1.1.254. And on switch 2, that is the case, we have the same IP address. The port channel, as you can see, is going to be pretty much the same. Port channel 30, not shut down, switch port mode trunk, switch port access VLAN 1, allowing VLAN 1 to go into that pipe, and also switch port, in this case, is going to be a trunk, allow VLAN 200, which is going to be a tag VLAN. And that port 30 is going to be part of the VLT port channel 30, part of that VLT1 domain. And over here in switch 2, you have the same configuration, because so even though they're in two different switches, they're gonna be part of the same pipe. We have a loopback interface that we're gonna be using for the OSPF OSPF process, and the IP address that we're giving it to this loopback for switch 1 is 1.1.1.1, just to keep it simple. The IP address that we're giving it to loopback 0 on the second switch is going to be 1112/32, and as you can see, there are part of the process OSPF 100 area 0, but this is the way we represent 0 in the switch configuration. And in switch 1, the same loopback 0 is part of the OSPF 100 area process. OSPF process 100 area 0. Okay, and then you have the management interface. One ends with 11, the other one ends with 12. If we keep on scrolling down, port 1 and 2, those are reserved for the VLTI link, and though they are in no switch port mode, because the VLT process will use those ports and is gonna auto configure them as part of the VLT the VLT domain, VLT1 domain. Let's go to switch number 2, and let's get up to that same ports. Yep, everything it has to be configured the same. Another tidbit is that you need to be running the same version of the operating system on both switches. 1.1.3 is going to be on switch 1 an uplink to that upstream router, and the IP address for that interface 1.1.3 is going to be 172.16.3.1/30. And then we need to make sure that we put that interface into the OSPF. I keep on saying OSPF 100 process area 0, and we're gonna do the interface 4 is gonna go into a separate subnet, as you can see here. And let's see what else I can say. Yep, and it's going to be part of process OSPF process 100 area 0. So let's identify those interfaces. Okay, so this is one switch 1 interface 1.1.3 going to interface 1.1.3 of the router over here, upstream router, and then 1.1.4 is going to switch number 4. So those are the interfaces that we were taking a look. Let's see what else we can do here. Let's catch up on this side. Let's see. So that's going to be 4. Okay, so let's just scroll down. Okay, and then you have 1.1.5 that is going down to the server. This is the port channel group 30. So basically we are making sure that this interface is part of port channel 30, and this is how we do it here. Let's see what else we have here. And then port 9, we have that port into switch port access VLAN 200, and because it's going to be part of 200, and the same over here. So those interfaces 1.1.9 is going to go to the PC, so that we can use to do pings. This could be an orphan port because it's only connected to a single switch, and it's not a dual home device like this switch that is mimicking a server. So let's go back here and continue. Let's scroll all the way down. I was thinking about doing the show commands, but I did that on the lab number 2. So whenever you have a chance, if you haven't, take a look. Yeah, just check it out. Let's see what else. Okay, so at the end you have VLT1 backup destination, which is going to be switch 2. These are the discovery interfaces 111 and 112. One thing I think we're doing different on this one, we're doing peer routing. So by enabling peer routing on a VLT domain, for example, one, what it will do is will allow each of the switches to route in behalf of the other switch, in behalf of the other multi-layer switch. So that way traffic doesn't have to go through the VLTI link, because the idea is to synchronize the routing table on switch 1 with switch 2, so that way they have the same routing table. So if a packet needs to go out once it hits switch 2, for example, and it's on the routing table, then it can forward that packet to the next hop, for example. And this is the virtual MAC address for the VLT domain, manually configured. In this case, we're using 0A, 0B, 0C, double D, double E, double F. The idea of using a custom made that you create or that you assign, or you can use this one if you want, is to allow for the process, just in case there is a failure in the topology. It's going to be just easier to have a common MAC address in both switches, and that way the convergence and whatever has to happen doesn't take too long. So that's the idea. If you don't put this VLT MAC address, then it's going to take a little longer to converge. No, not terrible wrong, but bad, but it can be a delay. So we have the same VLT MAC address in both switches. Within the VLT domain, both need to match. So let's stop there. Let's go ahead and fast forward a little bit here. Now that we talk about the main players here, right? And we already talked about the server, and we already talked about being able to have multiple racks with switches on the previous talk. So let's go ahead and let me get a sip of coffee. 1 second. Oh, that was good. All right, so let's log in. Admin. Let's do the same on switch number 4. Admin. Let's go back to switch number 1 and do that config. Config. What is it? Config no exec. And then just you can do write memory to save that running config to the startup config. Let's do the same here. Configure. Let's do no exec. Let's do write memory. Let's do end. Oh, I wanted to show you something else. Let's see here. Let's do the show running configuration, and there is a variant that we can use. Let me see if on this version is allowed. It's called compressed. So that way you don't have all the so basically with the compressed show running configuration compressed, it's gonna show the port groups that I was telling you about. It's gonna show you the VLANs, the loopback interfaces, the management, the ports that are actually configured, and that's about it. It doesn't have a lot of the ports that are not being used and configured. So that will save a lot of scrolling. Okay, well, yeah. Okay, so let's stick. Let's get back to the program. Okay, so let's go back to this launch OS 10 switch 3 console. So let's see what the instructions are. So we are already logged in. Let's see here. So this switch is already. Oh wow. Okay, I think I'm done on this one as well. For some reason I thought I didn't configure the switch 3 and switch 4. But let's continue with the lab. Let's see what else. So we did the configure terminal interface loopback 0 with this address 1113/32, no shutdown, IP OSPF process 100, area 0. And if you look over here, that's something we can do. We can just review and make sure that these commands are actually set up in the switch. Yep, I think that's gonna work. So it says here configure loopback interface 0 in this case, and define the OSPF process ID, which is 100, and the area is 0, which is the backbone. For the small company, as you grow your company or your divisions, then you might want to create areas so that way you can make your routing more efficient. Let's see what else. So let's move on to the next one. So then it says configure interfaces to the leaves and define the OSPF process ID and area. So in this case, what we're doing here, we're going into the interfaces. In this case, we're doing the interface 113 and the IP address of 172.16.32.30, IP OSPF 100 area 0. Exit. It's recommended that once you finish a block of instruction, just exit and then go back in this case into interface 114, which is going to be this one right here. And then on this one, we're going to set the IP address of 172.16.6.2, which is going to be a different subnet than this one. So this is 172.16.3, this is 172.16.6, and that makes sense. So let's continue. And then we're gonna go ahead and enable OSPF and save the configuration. That easy. So then we do the router OSPF, which is over here. And then another thing is that we're doing is to log the adjacency changes, just to see what's going on with your neighbors. Then we do the AND, and the right memory will copy the what is it called, the running config into the startup config. So let's go and move on to the next one. It says login to switch 4, and then login admin. We're going to I already loaded the. Oh, wait a minute. On switch 4, I haven't run. Oh, this is good. I haven't run the copy command to automatically. Yeah, I think okay. So yeah, we can do this by the numbers then. So on switch number 4 it's actually not configured. So because you see OS 10, it doesn't have the OS 10 switch 4 that it's supposed to have. So I didn't run this on purpose. I did this a few days ago. I have been extending this lab because I work and things like, life. So let's see here. Let me think about this. So we're gonna go ahead and go back here, and let's go ahead and drag these commands. And I hope this cooperates. There you go. Configure terminal hostname OS10/- switch 4, and we're going back into exec mode. Let's go to the next and see what else. Then we're gonna go ahead and configure terminal interface loopback 0 is gonna be created, and we're gonna assign to that loopback an IP address, which is gonna be 1114 because it's switch 4. We're trying to keep everything as logical as possible. No shutdown. IP OSPF 100 process area 0. So let's go ahead and drag those statements, those commands into the CLI, and then let's go ahead and hit enter. So this already configured the loopback interface and define the OSPF process ID and area. Over here we're gonna do configure interfaces to the leaves and define the OSPF process ID. Okay, so yeah, now we're gonna do the interfaces. And for some reason, let me see. I need to get better at this. Well, let's go ahead and drag over here. For some reason, there you go. Yeah, I just take I just had to click on the right place and drag it. Man, it's been a long day today. Today is Sunday. I just had some lunch. I'm drinking my coffee, and I say, you know what? Let's do another video because and the reason why I'm doing these videos is just for to help people that wanna download the GNS3 and start working on their own scenarios, right? Using Dell's virtual switches or Juniper or Cisco, and that way you can create a really cool labs without the need of hardware. I mean, there is a need for hardware, but by using this virtual environment, you can do very complex, powerful configurations that, you know, like especially like multi-tenancy, EVPN, VXLAN, and so more labs that I'm planning to do, VRFs. So even though I understand the concepts, haven't get to the CLA portion besides going into trainings, right? And because I don't do this on the day to day, I do pretty much the design, the architecture, that I know it works. It's just a matter of understanding the commands and the capabilities of the switches that really does help. Okay, so now that I went ahead and did this part right here, let's see here. I just want to make sure that, yep, that's it. All right, so let's move on. So it says enable OSPF and save the configuration. That easy. Okay, so let's take this over here. Configure terminal router OSPF 100, log adjacency changes, then and then write memory to save. So let's see what else is coming here. So now we need to go into switch 5. So let's see if switch 5, which is mimicking a server, is already configured. So it's over here. Yep, it's already configured. So let's do admin. So let's go ahead and check. Let's do config, and let's do no exec. Let's do show running tab. No. Well, whenever you are in config mode, you can do that do show running and tab, or you can exit, right, and go into exec mode and do what is it called, show running. That's why I was thrown off like one of the videos before, but now that since I'm doing this almost every day, so it's getting easier. The more you do things, the more you practice, the better you get. So practice make perfection. Okay, so let's do Control C to get out. I forgot to do let's do, because I was talking, let's do running show running configuration compress. All right, so let's do that. So now we see the port groups. Now we see the VLAN 1, VLAN 200. and it's already configured. Okay, so that's good. So let's move on to the next one. So over here it says to go into configure terminal, change the host name from OS10 to OS10 switch 5. In this case, it's already done. So let's move on to the next one. And then it says to configure VLAN 200 and give it this IP address. So yep, that's VLAN 200, and the IP address is 10.1.101/24. Keep in mind that on this particular lab, I added an extra command called peer routing that will allow each of the switch 1 and switch 2 to forward traffic at the layer 3 in behalf of the other. So that's good. Let's see what else. Interface port 30, no shutdown, switch port mode trunk, and allowing VLAN 1, allowing for all the untagged traffic, enabling VLAN 200 to be part of that trunk. Let's see what else. Then we went ahead into the interface range 1 and 2 for Ethernet 1.1.1 and Ethernet 1.1.2, and those two are going to be part of channel group 30, no shutdown. And if you remember in the topology, this is the port channel right here down here. This is the port channel, these two ports, right, 1.1.1 and 1.1.2. Let's see what else it says here. No shutdown and write memory. Yep, everything is working. So let's do some verification. We're about to finish. Let's go ahead and let's go to switch number 2. And so let's go here. Okay, now that we're in switch number 2, let's go ahead and do this. I'm just gonna drag it instead of typing it. Well, I'm gonna type it. I'm gonna keep it real here. So let's do show. Let's do IP OSPF neighbor. I'm just doing the tab and then hit it. All right. So now what is showing in over here on this switch 2 is showing the neighbor ID. In this case, one of the neighbors is going to be 114, which that's going to be the router on the right, top right, and then you're going to see 113, which is the router on the above switch 1 on the left, and so it's right here and right there. Okay, so let's go back to switch 2. So it says here the state is full, backup designated router, full backup designated router, and over here it has let me see if I can make this bigger. Okay, and then we have the IP addresses. Let's see what else. Oh, okay. Another thing I wanted to do. Okay, let's see here. So let's say that we are looking at. Let me just take a look here. 172.16.4.2. Okay, I think it's over here. Yeah, 16.4.2. Yeah. That is the IP address that is being identified by running this show IP OSPF neighbor, and the neighbor is going to be switch 4, and these are the IP address for that interface, 113. Okay, let me see if I can go back to that switch 2. No, switch 5. I'm sorry. There you go. Okay, so those are the what am I doing? Switch 2. Okay, switch 2. Okay, I know what it is. So let's go back here. Okay, so now that I already checked and made sure that we have the proper data. Let's check the next command, and this one is going to be show IP OSPF topology. show IP OSPF topology. I think, well, okay, so there. So now what we're seeing here on this topology, we are seeing that the router IDs, remember the loopback interfaces that we configure on each of the switches, and we're using a couple of them as mimicking routers, and one of them being used as mimicking a server. But let's say that they're all switches, right? Or they're all routers, and each one has their own router ID, right? Because they are multi-function switches with layer 3 capability. And we have 111, which is switch 1. We have 113, which is switch 3, and 114, which is switch 4. This one right there. Okay, so let's continue. Let's go back here. Yeah, I think I wanted to make this video a little shorter, but I guess it's gonna have to be what it is. In order to explain and to share. Yeah, so it is what it is. So basically, now it's saying that this is the next hop, right? You need to go to, in order to get to this to 111, it's gonna have to go through the next hop, which is 172.16.6.2. Okay, so let's see where that one is. 172.16.6.2. So which is this route right there. So basically you're going from switch 2 to 172.16.6.2 and then down, so that way you can reach switch 1. And then if you wanna go from switch 2, yeah, this is a little cumbersome because it's a virtual. Yeah, that's why I just need to be patient here. So going from to router 1113 is gonna go through interface 172.16.6.2. Yep, just to get to switch 3, to switch 1, to switch 3. That makes sense. Let's go back here, and we're about to finish this lab. I hope you kind of enjoy, if you haven't seen OS 10 before, operating system 10. Okay, so let's see what else. To verify the configuration. Okay, so let's try this command. Let's see, show IP OSPF routes. And over here we're gonna see all the routes. We're gonna be able to see the what is it called, the IP addresses for the loopback interface for switch 1, for switch 2, for switch 3, for switch 4, for example. The next hop, the cost, is an intra area, is part of the same autonomous system, is part of area 0, right? And it's gonna show us the 172.16.3, all these interfaces that are needed, right? That are part of the OSPF process. Let's go ahead and move to the next one. It says show VLT1 VLT port detail. So let's take a look, and we're in switch number 2. Let's go ahead and drag this one. Okay. Another thing I wanted to share with you that I didn't share on the previous video is that whenever you're creating the VLT domain, the VLT domain process designate or give it a unit ID to each of the 2 peers. So, for example, in this case, switch 2, which is going to be the unit ID 1, right? And switch 1, the unit ID is going to be 2. But that's just to identify what switch you're on, or and which one is the peer, for example. And in those 2 peers, we have port channel 30, the only port channel that we are using in this topology. If you have 6 racks, then you're going to have 6 additional port channels, just to give an idea, depending on how you configure it. So let's go to the next one, and that will end the this lab. And let me see if I can. Let's do show. Let's see here. VLT. VLT1. Let me see if I can do. Okay, show VLT1. Yeah, show VLT1. Okay, so this is what I wanted to do. I wanted to show you this. Let's go to switch 1 and let's do show VLT1. And I wrote it over here because I want to be able to show you all these commands, because I just want to make a few remarks. So let's go ahead and do switch 1 and then switch 2. That's good. Fresh coffee. All right. Let's see. Okay. So whenever you create a VLT domain, the VLT process will designate switch 1 in this case. For some reason, it says, you know what, you're going to be unit 2, and that's what I read on the user guide. And then for the switch 2, the unit ID is going to be 1. They both part of domain 1, which is the VLT1 domain. The role of switch 1 is primary, and the reason why is because since each of the switches have the same role priority, which is 32768, then what is going to decide who's going to be the primary and who's going to be the secondary is going to be the lower MAC. And in this case, switch 1 has the lower MAC, which is 34, versus the hexadecimal numbers that are over here, which is 58. So 34 is lower than 58, and this first hexadecimal digits 0C 4253 is the same in both switches. The only difference is going to be start in this other hexadecimal numbers, which is 34. It's going to be lower than 58, and that's why this one became the primary. Now once switch 1 fails or you reboot it, then switch 2 is going to be the primary, and that's not going to change unless you fail or reload, or something happens to switch 2. Then switch 1 is going to say, oh, okay, the other one is down, I'm going to be the primary. But that's the only way that you can change who's the primary for the VLT domain. Let's see what else. This is the VLT MAC I was telling you about. If you don't add this custom VLT MAC address, then it's going to take a little bit longer for the process to converge, just in case there is a failure in the topology. Another thing I read is that whenever you create in this MAC address, make sure that whatever you do not put a 1 on the last bit on these 8 bits, right? It's 4 and 4, that's 8 bits. So if you have, for example, it can be any number, but make sure that the bit on the right. Let me see if I can. I didn't want to make this longer, but I think this is worth mentioning. I will say, if you're safe, if over here whatever you do is not a 1, because then it's gonna think it's a multicast MAC address. So if you do 0A or 0B or 0C or 0 whatever other than 1, then you're good to go. And then if you're in doubt, you can always go to the OS10 user guide. Another thing I learned is that, for example, the delay restore timer, just in case whenever, let's say that you're going to turn on both switches, right? So what this does is that it will wait for the system to load before it activates the VLT ports and some other topology um, protocols, just to make sure that everything is up and running before you turn on this feature. So you can, for example, another thing I read is that you can go to switch 2 and increase, like I did over here. I went from 90 seconds to 100 seconds to allow switch 1 to boot, to load everything, to be up and running, and then 10 seconds later, then this second switch start activating the VLT ports, etc. Let's see what else. Peer routing is enabled. This is really cool. This is the feature I was telling you about. Um, let's see what else. This is the VLTI link status. In this case, it's going to be the special port channel, which is 1000. You don't create that. The VLT process will do it for you. And then if we scroll down here, we're going to see that the VLT peer version, right, and which is 2.2.3, and the MAC addresses, and the system is up. Let me see what other command I have here. Yeah, VLT backup link. That's, yeah, I showed you that in the previous video. VLT1 role. I already explained about the primary and the secondary. VLT port detail. I already did that, and VLT domain one already did that. And I hope you enjoyed this lab. It's been a little bit long-winded. So another thing I did on this particular one, I just changed the symbols, right, for the switches and routers and servers, right, even though they're all switches, that they can do layer 2, layer 3. I also did like a different colors, right, like for example for this subnet, in green, for example, and then you have this other subnet, 172.16.6, for example, in a different color, purple, and then over here the 172.16.7, right, with a different color, right? So that way you can see that you have 4 different subnets on this layer 3 routing space, domain. Yep. Let's see what else. I guess that's it. Yep. That will conclude this lab, and that's it.